Hi, Ragnar. I have a question. Do you also keep getting asked this? People ask me all the time, how do I overcome the instruction character limit in Copilot Studio and fit all of my agent instructions without running into the limit?
Yes, every single week, Tina. Like, honestly, I get it because now we are at a stage we are building real enterprise agents. So it's not just chatbots or FAQs. Things get complex very fast. So I hear that a lot, especially with our systems that are spanning across CRM, finance. So you got approvals and compliance and a lot of things to do. So before you know, we are definitely hitting that character limit.
So I guess the obvious answer is to create multiple agents, but then or do some kind of multi-agent architecture, but then you run into even more questions. When you have multiple agents, people start asking, how do I connect them? What if it's all one process or flow? Should I be using A2A protocol? And what are child agents?
Exactly. And that's what we are going to answer today properly, because my consultant answer is going to be it depends. But a framework, real examples, and 2 patterns you need to know in Copilot Studio: connected agents and child agents.
Welcome to In Our AI Era with Ragnar and Tina. This is our new podcast video where we talk about what we're actually seeing and building in the AI space. We'll talk about agents, the latest models, concepts we're trying out, frameworks that we want to share. We're really genuinely excited about this. Also, we're not just going to cover theory, we'll cover real stuff, real projects, things that we're doing in our daily jobs in this new AI era.
But firstly, Tina, I want to say welcome and congrats on your new role. For those who have not known, Tina has joined our Fast Track AI team. So we are very excited. So I'm really looking forward to working together on the team, but launching this in our AI era together. Thank you, Tina.
Okay. Yeah. Thank you, Ragnar. I'm super excited about this new chapter with our new team and within Fast Track. And speaking of new things, I have to tell you about my very first snowshoeing experience this past weekend.
Snowshoeing. Nice. How was it?
It was amazing, but it was also really challenging because we'd had gotten a lot of snow. So it was really deep snow, like kind of knee deep. And in the beginning, we kind of just set off and tried to walk on the snow. But then the guide told us it was important that we have the right technique and we should be working together as a group. So the idea is that you walk in a line and take turns to be the first, because the first person has to really make the tracks and go into this deep snow. And they have to do it in small, deliberate steps to kind of flatten the snow and makes a path. And so after the first person, there's still a kind of deep snow, uneven path.
So the path isn't actually walkable yet.
So this first person is going first and they're making, as much track as they can. And that's a lot of hard work. So we took turns. But then the second person also has a hard job because they have to step in the gaps. So they kind of take this 70% made track and take it to 100% by flattening all the snow that the person missed. So that behind them, the third person is kind of going through this highway of flattened snow.
Let me know more about this. What's happening?
While I was out trying to enjoy snowshoeing, I was actually thinking, this is a lot like AI agents, right? Because you kind of imagine that you're just going to sail through some complicated project with one person. But in reality, you lead multiple agents to solve a problem like this, right? The first agent goes and it wades through this thick, heavy snow and to maybe solve 70% of the problem. And then a second agent maybe comes in as a reviewer or to complement that agent and they complete the remaining 30%.
Exactly. And that is the multi-agent architecture. And what I love about this analogy that you're saying here is it nails the part that people are really missing when they speak of building these agents. Everyone thinks one agent is going to crush the whole problem on its own, but now sure, they are doing the heavy lifting and they still only get to 70% of their way, which might feel like a lot, but also it's not enough to get to your end goal.
Yes, exactly. And the second person is also not doing the same job, right? They're really doing the opposite and filling in that kind of gaps that the first person couldn't reach.
That's the whole point of multi-agents too, right? Specialized agents doing complementary work, not duplicating the effort. So completing each other, because that's the difference between child agents and connected agents. And that's what we're going to break down today in this video.
Okay, so here's what I keep seeing with customers. They've heard about agents, they've seen the demos, and they think, let's build an agent with our order to cash process. It's a great idea, but then they build one agent that tries to cover everything within this process.
Yeah, so one agent for CRM, finance, tax, discount, approval, HR.
Exactly, everything. And at first it works okay. But then the requirements keep growing, right? The business adds more edge cases, more tools, more topics, and then suddenly you get this giant agent monster that has 40 topics, 15 tools, instructions that scroll for days. And then, of course, the agent starts to get confused.
I see this all the time because it starts picking either the wrong tool or the instructions being ignored because we are contradicting one line to the other line below in the 70th line or 100th line. So hallucinating steps that aren't even in the flow are happening. So I agree, that's what's happening.
And this is, of course, really frustrating because, especially if you start as small and then add it to the agent, it was working fine the first 2 months. And then you kind of wonder what changed. And the answer is you've just hit a wall with too many. Once you get past 30, 40 choices, tools, topics, and agents combined, the orchestrator just gets confused and loses the ability to tell them apart.
Yeah, and the main thing is it's not that your agent is bad, right? It's that you've given too many ways and paths for it to go. And you're thinking, why is it not going in the path I want? It's confusing itself as well as making our experience feel like, why doesn't the agent work the way I want?
Because then it's not just ERP. I see the same pattern in customer service. So you build one customer service agent that can handle product questions, return, order tracking, billing disputes, technical troubleshooting, thinking about warranty, or scheduling field service visits. And it's the same story. It kind of starts small with some POC where which is working to show that the customer service agent could do some of this work. But then because it works, they start to add more and more until the agent is overwhelmed.
Yeah. And it's the same wall, right? But different domains, whether it's ERP, customer service, or sales. The problem is always the same.
Exactly. And this is a pattern I keep seeing. Repeat customers start with this agent, it grows organically. You really have this typical scope creep until one day it just gets too much. And then everyone says, look, AI is not ready. It cannot really take over the world. But it's not the AI, right? It's really the problem is the architecture.
It's a design problem, right? Not an AI problem.
Exactly. And that's where multi-agent come in. You don't need a smarter agent. You need to split the work better across specialized agents, each focused on what they do best. Think of it this way. You wouldn't hire one person to do sales, accounting, tax compliance, customer support all at once. You hire specialists. And that's what multi-architecture is.
Let's discuss exactly how to set that up then.
In Copilot Studio, there are two main concepts for multi-agent architecture. Honestly, the naming can be confusing, so let's make it simple.
Yes, let's define them clearly in these next two segments. So we'll start with connected agents.
Connection agents, the first concept or pattern, are independent agents that are built and published separately. So they have their own instructions, their own tools, and their own permissions, and they collaborate by handing off to each other. For now, let's just talk about the connected agents. And how you can think about this is perhaps like two departments. So you would have a sales department and a finance department, or let's say support and field service. And each department has its own team and its own systems and its own boss. But then, when a support ticket's created for an on-site visit, the support agent would hand it over to the field service agent. Or when, let's take the finance and sales, when the sales hands over the deal to finance. And they don't know each other's internal processes, right? They just pass the information on amongst themselves and then move on.
And technically, here's what it looks like in Copilot Studio. Let me give you two examples. In a scenario, we think of a customer care service scenario. You build a frontline support agent that handles common questions like your order status, returns, product information, and things like that. You build a separate specialist agent that handles complex technical troubleshooting like warranty claims, escalations. So each one is published independently with its own tools and permissions. Then you create the main orchestrator and connect both of them together. And you can call that your main agent that talks to and works with your employees in your team. And the second one, let's talk about an ERP scenario. You build a customer agent with access to CRM and Dataverse. So you build first the finance agent with access to D365 F&O. In our case, we have our Dynamics 365 ERP MCP server. Same idea, different systems and different agents, and all are working together with that one orchestrator.
So in both cases, the orchestrator decides which one to call based on what the user is asking.
Definitely. The orchestrator reads the descriptions of each connected agents. We'll put down some links on how the description helps them as well. And this is critical. The description is how the AI decides where to route. If your descriptions are vague or there is a routing problem, you should be very specific, and it works beautifully once you write those descriptions. And here's a pro tip from the things that we have built. Write your agent description like an API documentation, not just saying handle supported stuff. Instead, say resolve product return request, process refund, approvals, and tracks return shipping status. Requires order ID and customer email. Or for finance, you could create a different way to say create sales invoices in D365 F&O, calculates tax by jurisdiction, and applies volume discounts for orders over 100 units. So specific, action-oriented, no overlapping within the agents. So these descriptions really help you to find your orchestrator to find the right agent to go and talk to.
Descriptions are really important. But another thing that you should know about connection agents is that they can have completely different security boundaries. Your frontline support agent might see customer contact info and order history, but you might have a specialist agent that has access to the engineering documentation that are internal or warranty databases that you don't want the frontline agent to expose to customers. So and the same principle applies in ERP. Your CRM agent might see customer data. Your finance agent might see just the customer ID or order totals.
Now let's talk about child agents. This is the pattern 2 in our Copilot Studio. These are light page agents that live inside a parent agent. Think of them as focused subtasks. So let me give you 2 examples of these child agents to shine. But also to look back at our connected agents, one thing I wanted to share is when you have connected agents, they can work on their own as well. But these child agents can only work with the parent agent. They cannot be shipped and worked with other agents in future. So if you're thinking that way. First, sales. So you got a lead qualification agent. When a new lead comes in, there are multiple things to figure it out. Research the company, score the lead, update the CRM. You could cram all of them into a set of single instructions. But instead, if you create child agents, a company research child agent that will pull the graphics and other things that it needs for the recent news from your customer, a lead scoring agent can apply those policies that you have for your lead and ideally create that customer profile for you with criteria that you have, like hot, warm, or cold. A CRM child agent that logs the activity and moves the lead to right pipeline stage, and others can be happening. So within that one agent, you have each agent focused on one task for you, which is going to be testable, easy for you, as well as it's going to be a tangible solution if you're building all into one agent architecture.
So what I love about child agents is that they're also reusable, right? So let's say you have this lead scoring child agent. You just use it when leads come in through the website. You reuse it when leads come in from events and partners and LinkedIn campaigns. So it's a reusable unit.
Definitely. Build once, use everywhere. And also, as we both are in our Dynamics and ERP era, I'll give you one more example on the finance agent. Let's consider an example of an agent that needs to create an invoice. Instead of putting everything into the parent, you create child agents. So for every invoice, you can have a tax calculation child, a discount child, and an approval child agent. The tax calculation agent will do the tax for you based on the criteria. So you reuse this into purchase orders, expense report, and vendor payments with the same pattern, but they're going to be child within that own architecture that you're built.
And so the sales agent, the child agents will work the same whether you're in sales or customer service or finance. It's about more of a breaking the workflow into focused, reusable subtasks. Of course, this is going to look completely different depending what outcomes you're going to drive. And there's a great Copilot Studio training that we can link at the bottom, in which you build a customer service agent that has a child agent for each region. So how that works is you ask a question about US products that uses the child agent that only has access to the US product knowledge and prices. And then you have other child agents for the UK products and prices. What for me this means is that your agent architecture really needs to be planned. Right. So instead of just creating agents as you get an idea and as you think, oh, this could easily be automated, you need to have a structure in mind when you start. And let me go back to snowshoeing. Child agents are like those two snowshoers on the same trail. They work together. They're on the same path in the same direction, but they're complementary. and one does 70% and the other fills the gaps. So it's the same problem, with like, for example, one creating the base data and the other one reviewing their work. And then I guess connected agent would be like if you would have two teams of snowshoers, right? And one is in a completely different path. They're maybe on the forest path. The other one is on the mountain path. They don't even see each other, or they don't have to, but they might connect at the hut at the end of the day.
That's beautifully put, Tina. I don't know if I can connect all those things with your snow, but let's look at some real world walkthroughs then. What do you say?
Let's start with a scenario everyone can relate to: customer service. Because, even if you're not building ERP agents, you've probably called a help desk.
Yeah, great idea. Let's walk through the architecture. We have our main agent, which is the customer service orchestrator on the top. Then we have two branches. One is going to be a support agent, which means it is an agent that can be built on its own, then connect to our orchestrator. For the support agent, it's connected to, let's say, different MCPs for cash lookup, KV service, order tracking. And maybe that connected agent also has child agents underneath for sent and SLA, right? So we're going to put all the things in image. But on the other side, the same orchestrator is connected to another field service agent, which is doing your schedule visit, assigning your technician and parts inventory. And that connected agent can also have child agents for scheduling and diagnostics. So that's my best way to describe this, Tina. So let's see. And also we have the image up there on the screen for people who want to watch.
I like examples. So let's do one. Let's say for this example, there's a commercial customer that reaches out to the support desk and they say, the espresso machine that we bought for the restaurant stopped heating water. It's only 6 months old. Then the orchestrator would look at its connected agents and it would first route this to the support agent because there's a product issue, but at least not a field visit yet.
The support agent kicks off its child agent and says it talks to its sentiment of analysis of child, which reads the customer's message and flags it as frustrated but not angry with an important for the tone. The SLA check child can look at what do they have for SLA, looks up the customer's warranty and service plan, especially when it says 6 months old, still under warranty, premium support tier and other things are set up by that agent for it to proceed.
So now the support agent knows it's a frustrated customer, it's still under warranty and commercial customer, so we need to respond fast.
Firstly, the support agent tries the knowledge base first. So all of your agents will have knowledge. So it will look at espresso machine not heating and walks the customer through the rest of the procedure. But the customer says, let's say the customer says they already tried all of that.
So I guess now we're going to see the handoff.
It hands off it to the field service agent, which is our another connected agent from the diagram. A connected agent with completely different tools and permissions. It passes the case ID, the product model, warranty status, and especially the customer's locations, because the field service needs to know where they are. It doesn't need to know how field service schedule works. It will just hand it off there.
The field service agent takes over with its own agent. So it has its own child agent, like a scheduling agent. So it can check technician availability in the area. And then there might also be a diagnostic child that pulls up known issues for this model. And then when the technician arrives, he's prepared with the right parts.
And the customer gets one seamless experience. And the front end, the customer is not knowing which agent he's talking to. He's talking to the one place, but the agent goes and schedules a technician for them, and it will tell them between 10 and 12 tomorrow. They bring a replacement heating element based on the model. Our customer doesn't have to re-specify that again. The agent is able to identify all those things. So one conversation, two connected agents, and then below that, we have 4 child agents behind the scenes.
Yeah, and of course, this is all invisible to the customer, right? They just see the one agent that greets them. They don't see the one that's behind the scenes that's fixing the problem. So it's the same with the snowshoers. They're not seeing each other, but they're still meeting at the hut and achieving the same outcome without having to know how the other did.
Yeah, and one had a harder route than the other.
Maybe.
Okay, we'll go to walk way through. I have a very nice way to visually show this, Tina. We'll show this as an example. So I'm very excited for that. Now let's walk through a second scenario because we are core ERP customers that I work with a lot. So I want to give one order to cash example. This naturally spans across 2 different systems, which makes it perfect for a multi-agent use case with our customer and ERP. So CRM and F&O, both on Dynamics or others, we can show that architecture. So Tina, I would love for you to explain this image for us.
So this is the order to cash process. So you have an orchestrator, which is your main agent. And then underneath that, you have two connected agents. One is the customer agent, which is connected to the CRM through MCP. And then you have a second agent, which is connected to this one, the finance agent. And this uses the Dynamics ERP MCP. So it can do anything in the system, but it could specifically, because of the instructions we gave it, it can create a sales order and an invoice, and it would post payment. But then the key is here that it also has its own child agents. So it has a child agent that can do the taxes, a child agent that can do discounting, and a child agent that can do approvals.
And a user says, I need to just place an order for Contoso, right? The orchestrator then routes to the customer agent, which validates the account through the CRM MCP. Does Contoso exist? What is the credit limit for this customer? Is the product available? What is the pricing logged in? All within that one CRM security boundary first before it even does anything.
Is that then when the handoff happens to finance?
Yes, the customer agent passes that customer ID, line items, and what they are interested in. It is sent to a different system, right? So it sends it off to our finance agent, where this system with our MCP, it should be able to delegate those to child agents. It can look at task calculation child, takes the customer state, the order total, applies the right taxes for them. Then also it looks at the customer's history and looks at if they can give any discounts for this customer based on the number of units and things like that. And the approval child will check those totals. If they're over 50K, routes to a manager. Under 50K, you could set those rules. Instead of doing them as approval Power Automate flows before, you could do them all through natural language in these instructions for this child agent.
And I hope the pattern is starting to emerge, right? This is kind of the same thing that we had with the espresso machine customer service example. Connected agents are connected through at the system boundary, and then there's a child agent that is a specialist within each of these domains. And the child agents are reusable, right?
And for the viewers, if you're noticing, both these walkthroughs and two examples are exactly the same architecture, right? We have orchestrator on the top. Then we have connected agents for different domains or child agents but within each domain built the same way. The business scenarios can be completely different as well, customer service versus finance or ERP, but the pattern is identical. And that's the power we are thinking with this multi-agent architecture.
I hope that kind of clicks for people when they see this, because it does resonate with customers when we show it to them. It's not just about splitting the work. It's really about building a library of reusable agent capabilities. And then you go from building single agents to building really an agent architecture.
There's a reason multi-agent architecture is taking off now compared to like 6 months ago or 10 months ago or last 2 years, right? And the three letters are MCP.
Model Context Protocol, or how everyone likes to call it, the USB-C for agent.
Right. Before MCP, if you wanted your agent to talk to any backend system, like say D365, ServiceNow, Salesforce, or any of your internal knowledge base, you had to build custom connectors, manage those authentication flows, or handle pagination, deal with schema mapping. And also you have to deal with vendors if they allow you to read that through with an agent, right? So it was a project in itself for you, but MCP changes that by connecting it to systems seamlessly.
Yeah, and I mean, that really made multi-agents impractical, right? To have a project for every connection that you want to do. So, if you were connecting one agent to one system, it was hard. Like imagine building 5 agents and connecting them to 3.
And MCP changed that overnight, right? Like within 6 months, everyone is talking about MCP now. Every call we are on, CFOs, CTOs, everyone talks about MCP. And an MCP server actually handles those connections, not only the connecting to the data piece, but the authentication, the schema, the pagination. So all of it is done within that same MCP server. So your agent just says, I need to open case for Contoso or show me the sales order for Northwind. An MCP server handles that, the rest of it. Whether that's the Dataverse MCP for customer data, sales and service MCP for case management, especially ERP MCP for our finance and operation. Same pattern, but different data.
So really the barrier to multi-agent went from, I guess, months of integration work.
You don't need to think about connecting and all those things or building connectors. You add your MCP server to your agent, write really good descriptions, and short instructions, not too long, and then you're connected. That's why we are seeing customers go from single agents to multi-agent architecture so quickly now. We are seeing agents that have like 9 child agents, right? Whether they are customer service, sales, operations, or finance. And it connects borders across industries too. All the frameworks, we have Crew AI, LangGraph. The whole industry is moving towards agents that talk to each other in agentic ways. So I'm excited for that.
Yes, but in Copilot Studio specifically, you don't need all of these frameworks, right? It's good to know that they're there. But connected agents and child agents just gives you this multi-agent pattern natively or out of the box. And with MCP, your agents can actually reach the data that they need in real time. And as you've said, just through configuration.
And if you're building agents in Copilot Studio and you are not using MCP servers, you're making your life very harder, because I get this question a lot. Ragnar, should I build a custom connector for this entity or that? The answer is MCP, because we don't need to do any hard-coded API calls when an MCP can handle most of this.
Okay, so we've explained the two patterns, child and connected. But the question everyone has is, how do I decide? When do I know I should use a connected agent, and when should I use child agents?
I wish I could say very simple, but we also have a simple decision matrix here. We'll display this on our video here. So firstly, we have a table. Are you crossing a system boundary? Yes or no? If so, then it's a connected agent. Are these sub steps within the same workflow? Then it's a child agent. Is it a same team and a same system? Then it's also a child agent. So you could see all of this metrics in our example there. But the question, the use case, and we have some examples as well to help you understand how do we think about that. But also, I think looking at this table, you should be able to come up with your own reasons on the decision framework.
And it's important when you look at this to realize that it's not either or. I used to be a developer. And for me, this feels simple to deciding, should I use a method or should I use a class? And obviously the answer is you need both, right? As long as you don't create one method that spans 20,000 lines, it doesn't really matter how you do it. But you have to break up your logic into smaller pieces, into a larger set of skills, like a class. And then you have to break them up into smaller pieces that do one task, a method, and then you're good to go.
Right. And if you are listening, in both of our walkthroughs today, not like snowshoe walkthroughs, but the examples we gave, their connected agents are at the system boundary level. Child agents are within each domain. Whether it's customer service, order to cash, they all layer together naturally. And we have examples.
I think we haven't talked enough about snowshoeing today. Keep hammering on it. If you're doing the same trail, but with different steps, then you have child agents working on the same problem, but filling each other or, each other's gaps. If you have different trails that cannot see each other, separate teams, separate terrain, then, you have connected agents. But remember, they're still meeting up at the end of the day, so they're striving towards the same outcome. Then, of course, you don't have to have one or the other. You can have multiple teams doing multiple trails, all going towards the same, outcome with, 10 people in each group, right? So connected agents on two paths with child agents within the groups.
And that's the framework. Once you see it that way, the decision becomes obvious. And I'm already thinking of an image, Tina. Remember where there is you have two paths. One is the less traveled and the one is the mostly used.
Yes.
I think they're going to create one for you.
Yes, that sounds good.
Okay.
Okay, so we've been through patterns and we've done a couple of examples. Let's talk about a couple of things we're seeing in the field. So let's call these tips and things to look out for when you're building this. We're going to go back and forth, but I'll start. First thing is you should only split up your agent into multi-agents for a good reason. So that means that not every agent needs to be multi-agent. If your agent handles one domain, has 10 to 15 tools, and it works just fine, and you're not planning to scope creep and extend it, don't split it into multi-agent. It's like in HR, you see this, right? Someone builds a simple onboarding FAQ agent and it works great. But then they think, oh, what if we split it into, 5 agents? If there's no reason, don't do that. So if the test is if one person can explain what your agent does in one sentence, you probably don't have to split it into 6 agents.
Great tip, Tina. And the second tip I could think of is pick the right pattern for the job. So the one way to think about this, if both of the tasks live in the same system and use the same permission and are managed by the same team, child agents are your friend. don't reach for connected agents when you don't need to. Every connected agent also adds an orchestration hop and latency that you need to think about when you're planning this. So keep it simple when you can. For example, if you have an IT help desk agent that handles password resets, access requests, and known issue, those are all child agents within that IT support parent agent. So you don't need 3 separate connected agents for that.
Since I am the developer, my next tip would be that you should write the agent descriptions like API documentation. And this is very important to get right because that's how the orchestrator will know how to decide which agents to call, right? Your description is absolutely key. So if your description is vague, the routing is not going to work. And that means you need to not only think about your agent instructions, but also make sure you think about the agent description. And so don't put something like handles finance stuff. Instead, write something like, this agent creates sales orders in Dynamics 365 Finance. It calculates tax based on customer jurisdiction, applies volume discounts over 100 units, and returns invoice ID and total amount. Handle customer issues, resolves product returns, requests for online orders. And let me just say, it's so easy to write these days with LLMs. You don't even have to write this by hand. So there's no excuse to be lazy at writing. So be specific, be action-oriented, and make sure there's no overlap. And if you're unsure, put that in an LLM and ask it to review it for you.
I do that all the time, Tina. I never write instructions the way I think because the way I think of it is different than what the agent is thinking. That's a great tip as well, as an addition to how to write those instructions like API docs. I'm not a developer, but I definitely know some numbers. The next tip is around watch out the child agent count. I know we are pushing you towards this multi-agent architecture and we're sharing some examples, but don't have 20 child agents within that one parent, right? So look out for watch the child agent count. How many childs am I having? It's okay to have a connected agent with its own child agents in order for you to do that. So instead of having n number of child agents, think of 3 to 5 child agents per orchestrator so that it can do those things much properly and much better. So our finance agent has 3 child agents, task, discount, and approval. But our support agent has only 2 for SLA and other sentiments that we want to use. So keep it clean and manageable is my tip for number of child agents you have.
The other thing that I would say as a fifth tip is to check new MCP servers. So first check for an MCP server, but you also have to continue checking for MCP servers because there's always a new one, I feel, these days. There's also a Word MCP or Learn Docs MCP. And your agents are only going to be as good as the data they can reach. So you don't want to see people building custom API calls or writing Power Automate flows to fetch data or write to files. There's definitely an MCP server that can handle that natively. And the keyword is natively, right? So whether or not your data is in Dataverse or you need the service MCP or finance data, there's an MCP server. So check what's available before you start building. I know this is a simple tip, but it's very hard because these MCPs are now popping up like mushrooms.
Yeah, every time you search for one MCP, there are same for that same thing. So like Tina mentioned, look for the native one most cases. That's my best tip in there as well. And also, let's be intentional about our conversation history when we're building these multi-agents. One of the things we said earlier was the orchestrator will hand it off to child and child can send it off to a connected or something. When you connect these agents, there is a checkbox. Pass the conversation history to this agent. Sometimes you need to be careful on what you're passing. So sometimes you might need to have a filter there that doesn't pass everything. For example, in our previous one that Tina was explaining with the coffee machines, you don't need to pass all of the customer problems to a finance MCP in order to know which product to be ordered for the field service agent to go and fix the problem. The finance agent only needs to know the product name and few details that it needs. So try to think about, am I transferring the conversation history to different agents?
And the other thing that's often overlooked is that you always have to republish. You can make changes to a connected agent, nothing happens. And that's because you forgot to republish it. Connected agents always use the latest published version. So when you edit one, make sure you publish, test every single time.
Yeah, and for the publish, I have one more thing, Tina. I think I want to mention is when we are connecting child agents and stuff, if you have tables as well, Dataverse tables and stuff as knowledge, let's make sure they're in that solution and you have to go publish all customizations in the solution as well. Like Tina said, always republish and test as often as you can. I really like this audience challenge, Tina. So here's what I want everyone watching to do this week. Go look at your current agent setup in Copilot Studio or think of one agent idea that you can think of. Find one workflow where you're cramming too much into a single agent. Or initially, if you thought about a single agent, after this video, try to see if you can divide them into multi-agent architecture.
And I think the questions that you need to ask yourself is, does it connect across different systems? Or is this one child agent? Then pick one and try it.
Drop a comment and tell us what you built as well. We read almost every single comment. So this is your chance to ask us all the questions.
And if you're not sure, just describe your scenario in the comments and we can tell you which patterns fit. We've seen it all from help desk to ERP to sales pipelines. And, I also mentioned we'll pop in the Copilot Studio training in the description below. So if you're a complete beginner at this, there's a walkthrough that you can do to build that customer support agent that has a US and a UK child agent. It's really good training, so I would check that out.
I'm actually really ready to start the F1 series coming up. I watched the new Drive to Survive last weekend, so it was nice to revisit all the things that happened in last F1 season.
Nice. So do you also have some LinkedIn moment or something along the lines of, what I learned about multi-agents by watching Formula One?
As you were snowshoeing, I was thinking, we have this podcast that we're going to talk about multi-agents. So as I was watching Drive to Survive, behind the scenes, all I was thinking was, how can I explain this with multi-agents? In F1, a lot of people think it's just one driver, but there are 5 to 200 people working in real time behind the driver.
200 people just for one team?
For one car, not even a team. Like in team, they have 2 cars, right? So for one car, there are almost 200 people working together.
Whoa.
You got a strategy team back at the pit wall running thousands of simulations. Do we pit now or gamble for safety? A single moment of like one lap can change the whole decision of the race. So you got a pit crew of 20 people ready to change 4 tires in under 2 seconds, which is crazy to think. So you got a factory operations room that's also in the back end. Sometimes it's a completely different time and different country. A lot of these F1 races have engineering teams in UK and other places. As you know, F1 teams travel across the world. And also 30 to 60 engineers. What I learned was 300 to 600 sensors on the car. And you got a power unit team that's looking at how the power is delivered through the engine.
That's a lot of sensors and a lot of people. So what is the driver actually here? Is he getting input about all of these sensors all the time?
Driver only hears the one person, right? The race engineer. They sit on the pit wall, listening to several operators talking to them, strategy, engineer, pit crew, factory, and others. They filter all of that into one clear instructions for the driver. Simple thing is box this lap. They're going to say, this lap we're going to get hard tires, or they have to figure out, hey, we are going to undercut Verstappen, or we're going to take a loop or something like that.
No, I have a Dutch passport, so I have to be a fan by default. So are you saying that the voice in the driver's ear is an orchestration agent?
That's exactly how I was thinking of the example, but your snowshoe came in first, so I put it on the top. So exactly one voice to the user, an army of specialists behind the scenes, and every one of those teams is connected agent, right? The strategy team doesn't touch the car, the pit crew doesn't see the simulations. Everyone's doing their own things in isolations. They are connected agents with different domains, right? And the factory cannot talk to the driver directly. So different locations, different data, different permissions, they're all connected to that one race engineer, and from that race engineer to the driver.
I guess it's also orchestrating within the teams must also be a massive logistic challenge.
The pit crew, if for example, there's 20 people around that, there are 4 gun operators, 4 people pulling the old tires off, 4 people pushing the new ones, and then the jackman who will lift the wing and the front one. So there are all these people who are all working on just one task, which is changing the tires in 2 seconds. Not just removing the tires in 2 seconds, but removing them and attaching new tires. So each person has exactly one job. So the front right operator doesn't think about the rear tire. They're all focused on what they need to do. So this is like an example of how child agents are working just to replace the tires.
Yeah, it's exactly the same architecture, right? Connected agents are those team boundaries, right? Communicating between teams, and the child agents are doing their small specialized task within each team.
Yeah, and if anything, I want our viewers to take one thing as a takeaway here. If F1 team put 200 people on one radio channel, nobody would hear anything useful, especially Verstappen would be mad.
Yes, that's your single agent, right? With 40 tools and instructions, and it's reaching the character limit.
That's exactly what it is.
I'll give it to you. The Formula One metaphor is good. It really shows the complexity of agent architecture a lot better than, a couple of people snowshoeing.
We make a good team, Tina. I think you're bringing the practical things from one, and I'm bringing the one from the things I watch. I haven't never driven F1 car, so mine is just observation.
So this was our episode number 1 of In Our AI Era. What are we covering next?
Especially, I want to deep dive into MCP, how to set it up, and how it changes the agent architecture. Because we talked a lot about it today, and there is so much more. But also, I know you have other things that you want to talk before we jump into MCP as well.
I'd love to talk more about MCP. The other thing that I think we should talk about is the policy-driven agent pattern, which is one that doesn't just follow instructions, they follow business policies. I know you're building something like that for a customer.
I'm very excited to share that topic, Tina. We are calling it an EM pattern. It's like a framework that an agent can morph and learn from you. So you could train the agent with natural language. And we'll bring someone on that episode completely to help us understand how they thought about that and how this pattern is going to change and add memory to your agent.
So we should absolutely have more guests because I think it's very interesting to think how others are thinking about agents. So we could definitely do more on architecture patterns and just find out from other architects what they're up to. Thanks for watching the first episode of In Our AI Era with Ragnar and Tina. If this helped you think differently about multi-agent architecture, subscribe, like, and share it with your team.
We are going to be doing this regularly. And if you are building agents in Copilot Studio, you're not alone. We are all figuring this out together. So I'm very excited to share what we are coming up with, as well as share you the latest news with our podcast.
So see you in the next one. Bye.